Hello everyone, this is Suneel Maheshwari. You have probably seen the video that I prepared for learning the regression. What the objective of this particular video is to show you how to do some of the problems in chapter 12 and chapter 13 using Excel. So I will start with the module 11, chapter 12, and we'll go to exercise 12.1 first. And in 12.1, this is the first exercise that you should be able to see. Now, to run the regression, we have got the dependent variable, in this case, the salary, and the independent variable, in this case, the number of years of higher education. So a social scientist would like to analyze the relationship between educational attainment in years of higher education and annual salary in thousands. Now, to run the regression, you need the data. So you can click here on the data file, and you will find that this files open up. And in this case, we are assuming that the salary is dependent upon education, or the variation in the salary can be explained by the number of years of education that has been taken by any individual in this case. So you go on to data, click on data analysis, click on regression, and then the Y range is the dependent variable that we are trying to explain. In this case, it is the salary. And the X range in this case is the education. It starts from B1 to B21. Notice that I have taken the labels as well. So click on labels and hit OK. And once you hit OK, it will provide you the results in terms of your regression equation. So your intercept is 21.905, and your education coefficient for education is 10.85. Now, what does that mean? So your equation that you are basically using to estimate the salary based upon the education reads at 21.95 plus 10.85. So the coefficient for education is 10.85. That basically means with every year of education, the salary of an individual is predicted to increase by $10,850. This 10.85 is in thousands. So be careful about the units that are being used. So 10.85 is basically 10.85 thousand or 10,850. Now, what is the predicted salary for an individual who has 7 years of higher education? So predicted salary, you already have a coefficient intercept of 21.95, which is fixed. B1 is 10.85, and the education can be replaced by 7. So when you compute that, 21.9508 plus the coefficient times 7, it'll give you 97.91 or 927, so $97,912 is what is predicted as the salary for the individual who has 7 years of education. Now, what is going to happen is there might be an increase in number of predictor variables or the X variables, which might be able to explain the salary. For example, in this case, maybe the years of experience might be another variable, or maybe male or female can be another variable. But male or female is a categorical variable, and we can convert that into numerical variable by saying male is 1 and female not male is 0. So, and for any number, so we'll talk about those. That is called a dummy variable, and we'll talk about those as well. Now we are going to back to class exercises 12.2. Go to class exercise 12.2, going to number 1. So in this case, your wages are dependent upon saying education, experience, age. Those are the variables that are explaining. So you can run a regression instead of 1. Now you've got a multiple regression because you've got more than one variable that is explaining the changes in the wage. And this wage is an hourly wage rate. So we are saying that the hourly wage rate is dependent upon education, experience, age. So when you run it, these are the coefficients that you are getting: intercept 7.87, 1.44 for education, 0.45, and for the age minus 0.01. That basically means with the increase in age, the hourly wage rate might go down. So how do you interpret these coefficients for education, for example? Education coefficient is 1.44. So as the education increases by 1 unit or 1 year in this case, wage is predicted to increase by 1.44 hour, holding age and experience constant. Holding age and experience constant. So you are looking at the partial impact of the education on the wages. Similarly, interpret the coefficient for experience. Experience says 0.45. That basically means as the number of years of experience increase by 1 year, the wage is predicted to increase by 0.45 per hour, holding other two variables, age and education, constant. So the sample regression with this is 7.87, which is the intercept term. 1.44 is the education. That is, as we have said earlier, with a 1 year increase in education, the wage will increase by 1.44 per hour. And for experience, it is 0.45 increase in half per hour wages with every 1 year increase in experience. And as far as age is concerned, there's a decrease of 0.01 based upon whenever the age increases by 1. Now, how do you use this to predict it? What is the predicted hourly wage for a 30-year-old worker with 4 years of higher education and 3 years of experience? So over here, if you look at this, you have got the coefficients beta 0, which is the intercept term, beta 1, which is the education coefficient, and experience 0.45, and age is minus 0.01. So you can replace those numbers for a 30-year-old worker. You can replace this by age, by 30, 4 years of higher education. You can replace experience by 4, education by 4, and 3 years of experience, you can replace that by 3. So how it would look like is the estimate would be at around 14.68. So the hourly wage with the 30-year-old with 4 years of higher education and 3 years of experience will be around 14 points, is estimated to be at 14.68 per hour. Now, moving on to number 3 on 12.2. Again, very similar. You've got the accompanying data that shows the price, age, and mileage for 20 used sedans. So again, you can download the data, run the regression. What we are saying is that is the price of the sedan, that is the dependent variable y, which can that be explained by the age of the car and the mileage on the car. So again, you can click on data analysis, regression, and then your dependent variable y is, I guess it already ran the regression. I have to go back again, I guess. Make sure that it is done correctly. So data analysis, regression, your X range or the independent variables or the predictor variable that we're using is B1 to C21. So what we are saying, and then make sure labels is checked and then run the regression. So in this case, you've got age, intercept term, age, and the mileage. So both are negatively related with a negative sign on it. That basically means as the age increases, the value or the price of the car goes down. Similarly, as the mileage increases, the value of the car goes down. So that's the same number. That is the coefficients we saw earlier. So what we are saying over here, when we talk about the coefficient of age, which is 1 minus 1021, 82.82, that basically means for every additional year of age, the price of the car will decrease. The price of the car, which we are trying to predict, will decrease by $1,021.82. So how can you use this for prediction of a car which is 5-year-old and with 65,000 miles? So replace age by 5, miles by 65,000. So the predictor equation for the price would basically be the coefficient, the intercept 121,618 minus the coefficient for age 1000 minus 1021. Age is 5, and then coefficient for miles is negative 0.03 with 65,000 miles. And this will give you an estimate of about 14,005. It should say 559 or 562, one of the two. There's probably a rounding up error here. So that's how you will run those equations. Moving on to chapter 12, class exercise 4. Very same concept. Now we are going to look at . We have done this in one of the problems earlier as to how to make the hypothesis. So in this case, a small sushi restaurant is concerned that weak economic environment has hampered the foot traffic. So they want to advertise it strongly, and they believe that the advertising expenditure will have a positive influence on the sales. They have used the following regression equation. Sales is dependent upon the unemployment, that is, so people have the money or not, and then advertising expense. You have the data, ran the regression. Now, the question is choose an appropriate hypothesis to test whether the predictor variables jointly influence the sales. So the two predictor variables are unemployment coefficient for that is B1, and then advertising B2. So first null hypothesis is B1 is equal to B2 is equal to 0, or alternative is Bj, any one of these is not equal to 0. So remember I told you that when you start with the alternative hypothesis that is not equal to 0, it might be easier to write the null hypothesis from there. And the appropriate test statistics, since in this case is F value, which is 8.67760, and it is significant at 0.05 level. So at 5% significance level, do these variables jointly influence the sales? Yes, since F test is significant. So to test whether unemployment rate is negatively related with sales, so in that case, your hypothesis will change for both your null hypothesis and alternative hypothesis. This brings us to the end of chapter 12 exercises.